collision course. Imagine two archers, one on the Earth, the other on Mars. The arrows that they release must meet head-on with pinpoint precision. A task about as difficult as that has been solved by the Siberian nuclear physicists who have developed a method of colliding beams. What lies at the basis of this method? Beams of elementary particles travel at a fantastic speed on a collision course in the accelerator. The mysteries of the micro-world open up when they collide. The object under study is infinitesimally small, as many times smaller as a virus is smaller than the Earth. It seems it is possible to make an elephant out of a fly. According to the theory of relativity, the fly must travel almost as fast as the speed of light. In the same manner, the accelerated electrons increase their mass tens of millions of times. Does an elephant use up much energy when it collides with a fly? An accelerated particle that has become heavy loses very little of its energy when it collides with a light, immobile particle. But what if the beams of electrons are made to fly at each other at the same speed? They will crash headlong into each other and use up all their energy in the collision. This greatly increases the possibility of observing the life of elementary particles. Accelerators for this are much smaller and cheaper. The diameter of the accelerator's donut is about 6 meters. But a conventional accelerator corresponding to such an installation would have to be bigger than the whole world. Scientists in Siberia are studying the method of colliding beams and are accumulating antimatter, a fuel billions of times more concentrated than oil, a fuel capable of propelling spaceships of the future to distant stars.